So instead, what we are trying to do is to discuss networking, right, as basic as possible. But then while doing that, we are also going to be building out some few projects and then be seeing things like how things go from one side to the other. Right? So in the beginning, I'll be using this interface, which is called Cisco Packet Tracer. Okay, so it's a simulation environment where we use to learn networking or to simulate network behavior. So you can see there are some PCs, there are some other things over here. We are going to look at them and then we are going to talk about a few other things too. Then after we are done, we are going to use a much more realistic tool, which is called GNS3, to talk about most of the things. But for you, if you're not into networking, you don't have to worry about this in particular. I'm just trying to use these tools to make it easier to explain them, right? And this is more of where I come from. So what is going to happen is we are going to take a look at some of the devices that we use in networking. Then we will talk about networking in general, right? Real general. Then we will start building or just putting together small networks. We explain them. We put together another one. We explain it, right? So that's how the session is going to go from one side to the other, right? So before we start, or as we have already started, I'd like to ask if anyone has any understanding of what we mean by networking. It doesn't have to be computer-based networking, but if you like basically anything you know about networking that you would like to share, could you say that? Like you can unmute and then you can uh, share with us what you think a network is. Go on.
My point of view in network, my point of view can be seen as um, a connection between devices, at different locations so that they can share information or data between one another and actually, yeah, share data basically. That's my point of
Yeah,
view.
that's amazing. That's great. I mean, that's really what a network is. But anyone else with something different or to add up, or if you also agree, you can say that. So I'll take one more, then we continue from here. Yes, Israel.
Okay, I can say networking is like when two different entities or elements of that have same similarities, they share um, information within and between each other using a medium, like something that will help them to transmit what they want to share.
Okay, that's great. Yeah. So also good. Yeah. The only part that I'll probably maybe ask you to maybe rephrase would be the part where you are saying they are the same entity, right? Because as you would see, you would see that like different networks that are sort of even from different vendors can communicate with one another, right? So it doesn't really have to be of a specific or same entities, but that's also correct. And that was how networking was in the beginning, before we had the OSI and then the TCP/IP, which we will discuss very shortly. So yeah, network is a combination of whatever you guys have said. And I hope everyone here is comfortable with everything that we've said so far. We are saying that a network is essentially a connection of devices for the purposes of sharing information. Okay, so the sharing of information can be files, can be data or internet, anything you can think about with network, right? So currently we are even on a network which allows us to be here. Okay, so um, there are some things that make these things possible. The most important part is really your device that you have at this point. It could be a PC, a laptop, a phone, right? A tablet. a phablet, in any device that you are using to access some form of a network is a device which we can also talk about. All right, so you can see over here that I have a PC here, which is more useful, like more very known to us. Then I have also this thing here. You can see the name down there. It's called a switch, right? And these things, I'll be showing their graphical or their physical representation shortly. So when we see something like this, like an icon like this, we call that a switch. And essentially, what a switch is that it is able to take information from one device and then take it to where it's supposed to go using some address called a MAC address, which we will see shortly as we go forward from there. Right. So essentially, the switch is a device that is in between hosts. Okay, and when I say host, I'm just talking about the devices that I just mentioned there, the PCs, the phones, the laptops, those kind of things. All right. So when we talk about hosts, most of the time we are talking about network devices that are receiving, or let's say devices that are receiving connections, or let's say are being served some form of data. Right. But when we say a host on a network, we are basically talking of anything on the network that can, let's say, share information or receive information, right? Just to keep it much simpler. Then we also have this guy here called a router, which is in charge of taking whatever is from one side of a network and then taking it to another network. Okay, so now we will come back and then explain what I mean by this one being able to take information from one host and then taking it to someone else on the same network. Then how this other guy here, the router, takes it from one network and then takes it to another network. All right. There's also these devices here, which we can call them firewalls, right? It does other things too, right? But you can see that they have these things over here, and probably they are not very clear. I'll increase it a little bit. You can see we have something like some bricks over here. Right? So we call this on the firewalls, and it does some other form of intrusion prevention systems or like intrusion detection, other stuff. But for now, what we would just call it is a firewall, and a firewall is just a device that is able to block or allow certain connection or traffic to your network or in and out of your network, right? And this guy over here, this cloud in networking, when you see this, we use this to represent the internet or any network that its details are not important to us, right? So let's say I'm trying to talk about something and I don't need to tell you all about the details of that specific network, but I want you to know that there's a specific network like that. I'll just put this cloud icon over here for you to see that, well, there's a network over there, but then the details are not important to what we are talking about. Okay, so it's either we use this for the internet or something that is off of our network, or to say that the details of that network is not important to our discussion. Okay, so this will do for most of the things that we are going to be using. We need a PC, we need a switch. So again, the switch is the thing that is going to go in between host devices, or let's say clients. All right, so when we say clients, it's more of like your PCs or laptops, those kind of things. All right, and then we also have these devices, the switch, the router, and those people. We normally call them the intermediary devices because they are standing in between your PC and wherever you are trying to go. Okay. So when we talk about the switch here, it's just a device that is in between the hosts. Right. So we can connect these two pieces to this host, sorry, to this switch, so that when I send something from here, this device will see it and then know that, okay, well, it has to go to this device, then it will take it there. Okay. Then there's another form where maybe I'm trying to send something from this PC all the way to the internet. Okay, so at this point, the information I'm sending is not going to go to this PC, right? And the switch by default, it's not able to go to the internet by itself, which we would explain why very shortly. So it has to send it to another device which is able to do that. And probably from here, you'd understand why you have default gateways. All right. So this switch over here knows that, okay, well, this is not something that I can do. And the host will make sure of that. And we would see and set some of these things as we go. So the thing that I would like you to see at this point or to take note of are the images, how they look like, and how we are going to be using them, right? So a PC is what you are used to. A laptop is a laptop. Your phone, your tablet, those things, right? They are the end devices. Okay. So and then the things that are within the network, as in from the point of origin to wherever it gets to, those are the devices in the middle, right? So we call those guys the intermediary devices, the switch, the router. We can also say the firewall, right? So these guys are the things that allow you to move from one place to the other, right? So if you're on your phone's hotspot at this point, your phone is serving as your router. If you're on a company Wi-Fi or you have a router sitting somewhere, it's your router or your MiFi, right? That's your router. Okay. So basically you can say that anything that allows you to get access outside of your network is a router, right? And anything that allows you to communicate with other devices within the same network that you are on, we term that as a switch, right? And like I said, we are going to see what I mean by these things as we go forward. Okay, so all of these devices have where they apply. Okay, so I just like to use a few of these devices to just show something. Then we would use the understanding that we are going to get from this side to basically also try to build out some more understanding. Okay, so most of the things that I'm going to do here might be new to you, which is fine, and I'll keep them mostly simple to make it easier to grasp, right? So the very first thing that we are going to do is going to be a very simple network. It's what we call a peer-to-peer network, right? So uh, give me a moment. Let me remove some of these guys. Okay, so I'll remove all of these things. Okay, and I'll just leave these two pieces. All right, so at the very bare minimum, right, we can have a network with just two pieces, and we call this a peer-to-peer network, and all that we need is a cable to just connect from one side to the other. All right. So before we even get into, let's say, trying to build out the networks and these kind of things, there's a conceptual model that allows us to do more of these things, right? So I have this same connection over here at another place, but I'll use this one for a while to explain a few things visually so that we can see that. But then for the purposes of making it um, realistic, we are going to be using uh, the uh, the other one that I mentioned. Okay, so for here, all that I'll do here is just I'll come to this side where the Thunderbolt is. If you're interested in getting this app, you can go to netacad.com, netacad.com. Right, you register for an account, then you can get access to download that. It's mostly used amongst engineering students or people who are learning networking. Okay, so you can check it out anytime that you are free or you want to check it out or something like that. Okay, so now you don't want to have to worry about these cables for here. Like our focus is not really on the networking, let's say as a networking person, but to understand it to a certain level though. So here, all I'll choose is I'll choose this particular one here, which is going to just automatically select the best cable to use. So here I'll connect one from here and then connect that to the other side. Okay, so essentially what I've just done is I've connected one PC to the other PC. Okay, so now to make this possible or to actually make us use this correctly, we would have to set something, and we call that thing an IP address. Okay, so most of these things that I'm doing is just let's say a background to just set most of the things up, right? We will break all of those things down as we proceed. So we will have to set something called an IP address, and an IP address is essentially like a post address, or think of it as a number that we are able to call, and then we are able to know who that who that IP address belongs to. Okay, so you can think of the IP address as the phone number of someone that you know that you call. Okay, so um, if you're in Ghana, then the number is usually 10 digits. If you're in a different country, it could be different. Right. So in networking, we also have this uh, standard called IP addressing. So there are two forms, but the one that we will talk about in this session is going to be the IP version 4, and we will explain more about that. So what I'll do is I'll create them, and then we are going to just have a look at it shortly. Then we are going to build upon most of these things as I would explain more of the OSI and then the TCP/IP. From there, we will break this and much more down. So here, again, like I said, if you're not conversant with this, you've not seen this before, it's fine. But what I'll do is I'll come to the desktop. Okay, then I'll go and select the IP configuration. So you can see currently I'm on PC 0. So I'll select that. Then what I want to do is to set an IP address. Okay, so we'll see how to do all of these on a real device. Okay, on the other side. So here, what I'll do is I would give it an IP address of 192.168.10.1, and we would explain all of these things shortly. Don't worry about that yet. So I'm giving it an IP address of this 192.168.10.1, and then also a subnet mask of 255.255.255.0, meaning that the network that I'm giving or I have over here is going to be able to go up to a certain point, which we will get to shortly, right? So there's also the issue of the default gateway, which we wouldn't set at this point, and then the DNS server. So the DNS server is what allows you to translate names into IP addresses. So when you go on the internet, you just type www.google.com or www.twitter.com, and you don't think about it, but in the background, these things are happening. It is taken from the name to an IP address, just like the way that when you are calling a friend, you go to your contacts, select their name, and you call them. But then actually, what you are calling is the number, not the person's name. But it happens so well that you don't think about it. It's something similar to how the internet also works or how networking works. Okay, so I've set this one for this. What I'll do is also set it for the other person as well. But after you set this, what I'll do is close out of here, and then there's this command prompt. So if you're on Windows, you've probably seen this before, but there's no Windows per se, but it has a similar feel of it. So what I'll do is I'll just write ipconfig, and you can see that the IP address that I set is over here. Okay. So the other thing that I'll do is also come to this PC and then set that one quickly. This one will be 192.168 10.2, and that is also going to be populated correctly. Then I'll check the IP address of this one here. Quickly, could you confirm if the text here is clear for you? I think it's small, or you can see that.
Yeah, that's what I wanted to say because I'm not seeing it clearly from my end. I'm not even seeing the.
Oh, okay, sorry. Let me try to up it a little bit. Probably, let's say something around here should be okay. Nope. Did I?
Hey man, Max.
Yeah, hello.
How are you, man?
I'm good. How are you?
Oh, I'm good. Sorry for being off topic, right? I just wanted to know, like, is it going to be possible that we go and maybe, have some PLD over the test driven development topic?
Okay, well, that could be for another time, but today we are trying to talk
And
about
I'm not speaking
net.
about, I'm not speaking of
Yeah,
today, but I'm just saying maybe sometime.
yeah, well, yeah, that'll depend on the interest. So we can talk about that
All right,
maybe after the call.
no stress.
All right. So
All right.
hopefully the text is bigger now, right? Is it clearer for everyone to see? Is the text okay for you guys?
I cannot even see where you're typing at. It's not showing on my end.
Yeah, I'm not seeing the place you're typing. I'm not seeing.
I think you share
Oh, good.
just the windows that you are building the topology on.
Amazing. Okay, well, I'm not home to share just that particular screen too. Okay, well, let's go full screen then. All right, so here's what I'm trying to talk about. Then probably maybe you missed some of the few things that I mentioned, but hopefully it's up now. You can see everything with everything. Right?
Yeah, now we can see.
Okay, yeah. Sorry about that. I was thinking that it was showing up. Mostly is on a different screen, but today I happen to be somewhere that I don't have an extra screen, so sorry about that. Okay, so essentially what I'm trying to say is that I've set up the IP addresses for these two devices. Okay, one is 192.168.10.1. This one over here is this, and then the other one that you just saw. Right. Okay, so these are the two devices that we have, right? And then when we have a network with just two devices like this, we usually call that a peer-to-peer network, and you've probably done that a lot of the times. For example, when you are connecting to Bluetooth, right? Like if you have a music player which is a Bluetooth, when you connect to that, you are essentially doing a network connection, which is just between you and the Bluetooth device. Okay, so there are a few more that we can talk about, but they're keeping it just to like developers, what we would have to worry about. Okay, so after we are done setting up a network, one of the things that we have to do is to confirm that it's working. And so we usually use the tool called ping, which is to test for connectivity. It sends some things that we will talk about later when we get to the other side. Okay, so here, what I'm trying to do is I'm going to say that, okay, well, from this PC over here, I'm going to ping or check whether I can reach this device on my other side. Okay, so what I'll do is I'll just say ping 192.168.2. So think of this as calling your friend with their number. So I'm calling my friend, and looks like the call is going through and it went through correctly. Right. So here I can see that I got a reply from the other side. Okay, so we are going to be demystifying these things as we go along. All right, but for now, I'd just like to ask, like when it comes to what we mean by a network, and some of the few devices that we mentioned are part of network devices. We saw the switch, we saw the router, we saw a firewall, and we also saw the cloud, which we say is used to represent the internet or a network that or a network whose details are not important to the discussion. So if you have any questions, you can bring it up and then I will try to answer them before we continue. And as you can see, I'm not on the like the call to see if you raise your hand. So you can Okay, well, I think everyone is okay at this point. All right. So now, before we can really understand how networks work, you would have to understand a few things. Okay, there's these two models that we use in networking. One is called the OSI model, and then this other one is also called a TCP/IP model. So the first one that we will discuss is called the OSI model. And as you can see from this side, we have this here, and then we also have this here. Right? So when we talk about the OSI model, we see that it's mostly a reference model or a conceptual model. It's not something that we actually use. It is just to sort of explain how things are working, right? And then the TCP/IP model is what we actually use. Right? So currently, the network that you are using currently is an implementation of the TCP/IP stack. Okay, so we first discuss what the OSI model is, and then everything else that we are going to discuss on from the OSI model is directly almost the same as the TCP/IP model. Right? The only difference that we usually have is that we see for the OSI model we have three different places or three different layers. That's how we call them. Three different layers for specific things. But for the TCP/IP, it's all been combined into one. All right. So let's talk about the OSI model just for a while. So the OSI model, it has these 7 layers. And as developers, what we really worry about are the application, presentation, session, transport layers, and sometimes the network side, right? But if you are a network engineer person, you are worrying about from the physical layer all the way to the transport layer most of the time, right? So mostly the application developers are mostly only interested about application layer, right? Which is the application, the presentation, and also the session, right? So I'm saying that because that is how it is in the TCP/IP, which we'll get to. So we'll take it from the application all the way to the physical layer. Okay, so usually maybe this might be something that you might forget, and we have an easier way to remember it. You see from the P, D, N like that. We usually say, please do not throw sausage pizza away. Okay, so please do not throw sausage, sausage pizza away. Okay, so that's one way that you can use to remember this layers. Okay, so starting from the application layer, it is where we sit as users. Okay, so for instance, how I'm sitting here as a person using something, right? And when I say application layer, don't think about your browser or your like the application that you use, right? This application that we are talking about is not in terms of the programs that you are using. It's rather in terms of certain ports that is being used. Okay, so we'll get to what ports are, and that's mostly what I'm talking about applications. So you see, there are multiple applications that we are using. For instance, currently we are using the browser to do certain things, right? We go to the internet, for instance, when I go to www.google.com, there's a specific thing that is really running that. And I'm not talking about your browser, whether Chrome or Safari or anything like that. There's an application that allows you to work with web pages or see web content. Okay. And also, if you are streaming video, there's a protocol or an application that is allowing you to be able to do that. In the same way, if you are, let's say, doing FaceTime or anything that you do on a network, there's an application that is allowing you to do that. And you don't have to confuse that with um, the 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 program. Okay, so when I say application, don't think about the program. Think of it as a protocol that allows you to do something. Okay, so this place is where we sit as users and we start something. Okay, so for instance, now if I go to somewhere here and I type something like, let's say, google.com. Right. So when I type this google.com, a lot of things happen, right? But then, though I use a Brave browser to get here, this one application we are talking about, there's a specific protocol that allows us to do that. And that is what we mean when we really talk about the applications at this level. So this application here is mostly what we are used to as, let's say, the HTTPS or the HTTP, which is an unsecure version. So really what I'm trying to talk about here as in the protocol is this over here. So this is the application that is allowing us to access the internet, the HTTPS, not the browser. Okay, so I understand that the browser is an application, but in terms of this networking that we are talking about, we are not talking about the program that you are using to run it. We're talking about the protocol that allows you to access those things. Okay, hopefully that is clear. Very good. Okay, all right. So the application layer is where we, again, we sit as users and we make requests, we ask for things and multiple things of that sort. Okay, so also the presentation layer is just as you may think about it. It's how the things are presented to the person who is receiving it. If it is an ASCII text or if it is a picture, if it is whatever, like how the thing needs to be presented in the way that it has to be presented. That's what the presentation layer is really all about. Okay, so if you are sending some form of information that is in Arabic or something of that sort, you expect that when it gets to the other side, the person receiving it also gets it in the same way. So that is what the presentation layer is mostly doing. It does quite a lot of things, encoding and decoding those things, right? And then for the session layer, it's really just as it's saying, is the one that is in charge of creating up and tearing down sessions. So for instance here, you see, okay, let's use this as an example. When you are going to call a friend, right? When you call the person, you start hearing that there's this kind of beeps that are going on, right? So at that point, you have started a connection or a session to your other friend who you are trying to call. The moment they receive the call, you've started a like the session has been open for you to talk and whatever. For instance, as we are on this call at this moment, we are on a session. Right after we are done and we hang up, we are closing or tearing down the session. Okay, so this session here is essentially just saying that when we are trying to do something, we start it up. After we are done, we close it down or we tear it down. All right, that's what the session layer is all about doing. Okay, then we talk about the transport layer. This transport layer guy is more of something, and I would like to bring up some notes that I took back then. Okay, so I'll probably use that as an example and something like that, right? So the transport layer is more of like your door. Okay, so we would be going in that way. So I mentioned application, but this is on the TCP/IP, but we would use this as an example. So the application is, like I said, like the thing that you are using to access the information, right? And the presentation is where you get or anything that is in charge of making sure that you are getting the data in the way that it is expected of you to get it. That's what it is. Okay. Then the transport layer is essentially, we can talk about it as your door, where you're going to receive that thing. Okay, so like where you receive it, that is what the transport layer is doing. It is in charge of sort of listening and then knowing that, okay, well, now this thing or this box is at my door, so I need to go and get it. Okay, so the transport layer is in charge of that. And maybe you might be thinking, okay, well, maybe the transport layer should rather be the car, but we'll get to that. Okay. Then we also have the network layer, which is what we are talking about now. It's what is able to sort of say that, okay, well, from here we have to move to this side, or move from here to the other side. So it's the general overview of, okay, well, if we are in this city, we have to use this lane to get to this side. Or like, I mean, we've all used a map before. We've sort of said that, okay, well, if I'm here, I'll move to this side, I'll move to that side, and then I'll get to where I need to get to, right? Or basically the ability to move from point A to point B, just as we are seeing over here. Then you also have the data link, which is more of this place where you saw the switch, which we'll get to. Okay, so the data link is the almost close to the physical layer. Okay, so sometimes the data link and then the physical layer are a little bit, or sometimes put together. Okay, so the data link is like the kind of, let's say, standard we use to connect our information. So for instance, currently I'm using a Wi-Fi to do what I'm trying to do. If you are using, let's say, a cable to your laptop through your phone, maybe you are tethered your phone to your laptop, or maybe you are using some form of other thing. So like the data link is in charge of these kind of things. The kind of communication method that we use, either Wi-Fi or cable or anything in between. Okay, so that is what it's in charge of. And then the physical layer is really about the actual cabling. Okay, so maybe that might sound a bit confusing. That's why I was saying that sometimes these two things are put together just to make it easier. But really, the physical layer is the actual cable that we are using. Okay, but then these other things are some other things that maybe we wouldn't have to really worry about as software people. Right. Mostly our concern is on the application and then the transport. We don't really worry about this one. But since we are learning about the TCP/IP, you have to go through that. Okay. So the application is where you start from. That is like, let's say, the top of the food chain, and your data goes all the way down. Right. It's just like you drafting a letter. After you're done, you have to take it to the post office for it to be delivered to wherever it has to go. Okay, so there's a lot of things that starts from the top to the bottom, and also from the bottom back to the top. Okay, so when we are talking about this OSI model, it is really just a conceptual model of how things are working. It's not what we actually use. But everything that we said about the transport layer, the network, data link, and physical layers of the OSI model are the same as for the TCP/IP. The only difference is that everything, these three things here have been merged into one for the TCP/IP model. So the real difference here that we can say is that the OSI model is not really an implementation. It's just like what we use to explain how things are going, or like, let's say from here it goes here, or from there it goes there, right? But the TCP/IP is the actual implementation of the network that you are using today. Okay, so every network in the world at this point is using the TCP/IP model. In those days, there were other kinds of models that we were using, and as Israel was saying, that there had to be like some entities of the same kind, right? TCP/IP deals away with that. It's able to work regardless of the network type that we are using, or devices in the network. Some time back, if I have Dell laptop, I should be only able to communicate with only Dell laptop. Or if I have Android phones, I should be only able to communicate with Android phones, because the network stack was made specifically for Android or iOS or those kind of things. But the TCP/IP model sort of standardizes everything so that we can all communicate without having to sort of worry about all of these other stuff. Okay, so the TCP/IP model or the OSI model is something that maybe you would have to take some time to wrap your head around, but it's the step-by-step process in how we used to actually also troubleshoot. And it's the, let's say, the bare minimum of what we need to understand to get a better understanding of how our network is working. But like I said again, mostly for the software engineering people or for software people, mostly your concerns are on the application side and somewhere around the transport. Right? But most of the time, knowing about these layers is going to be helpful. And like I said, if it's a lot for you to memorize, there's like a mnemonic that we use. Please do not throw sausage pizza away. So please do not throw sausage pizza away. That's from layer 1 all the way to layer 7. I think there's one for from layer 7 down to layer 1, but I can't remember that one. There's this one I think is the most popular. Please do not throw sausage pizza away. So that's really most about the OSI model. And what I'll do is I'll just bring up a few things that I just mentioned. Okay, so the application layer, it consists of the application that you use, or that the application that use the network, the HTTP, the SSH, those things, right? Not the browsers or those kind of things, not them, right? And the presentation layer is what standardizing data presentation to the application. So if you send a picture, you expect that you expect that a picture is going to be shown on the other side. If you send an ASCII text, it should be that same way, right? The session layer is also in charge of managing sessions between applications. Let's say if I'm trying to call someone, there should be something that is going to hold up the call until we are done. Okay, then the transport layer is providing end-to-end error detection and correction. There's more to talk about that, but because we're not doing networking like into detail much, we wouldn't go much there. The network layer is in charge of managing connections across network for the upper layers. So like from the network layer down to the physical layer, that's where the devices that we talked about come in. Right, the router that I mentioned is or it lives at the network layer because I mentioned that the router is in charge of connecting networks together, or it sends data from one network to another, right? Then the data link layer is in charge of providing delivery across the physical link. So the switch that we mentioned, right? The switch is in charge of taking the data from one host to another. Okay, so we are going to see this in a simulation environment, and then I think most of these things are going to be easier to understand. So before we do that, okay, let's take a question, or if someone has something to say about this one, then we can talk about that. But I understand that the OSI model might be a little bit something to wrap your head around, but with time it would kick in, and we would also like to try out some few labs as we continue. So if you have a question, you can ask it, and then let's try to answer it as best as we can.
Hey, Max.
Yeah.
You mentioned that for us as software engineers, it's going to be very helpful to know networking. I wanted to understand at what degree is it going to like be helpful towards us, and where are we going to find it very helpful or sort of a need into our profession?
Okay. So like I was saying, right, with for the software engineer person, or the one who developed the software, right, you probably want to communicate with some devices, right? Or you need to develop sockets, right? Or to put it simply, you see the let's say you've used SFTP before, right? Or you've used SSH before. So if your understanding of networking is not there, some of these things you can't do them. Okay. And you don't have to be a network engineering person like someone who is really dense in networking to do that. But an understanding of how things move about, okay, is all that you need as let's say someone who is just interested in building applications. Okay, because at one point in time, your solution might have to communicate with another thing. Okay, and you would have to be able to know how to make that connection work. Okay, so that's a few things because, for instance, you are going to be connecting to databases, and you would have to understand the concept of what a socket is or some few things. Okay, so it's not really about understanding it as a software, sorry, a network engineer level understanding, but even the basics of it is going to be useful to you. You're going to be working with all these things every time: IP addresses, port numbers, those kind of things. So those are the areas that mostly um, software developers or software people mostly concentrate on. Does that answer your question?
Yeah, thanks for that. Now I understand.
All right. Anyone with a different question?
I would also like to ask, is it part of the ALX curriculum? Because I saw something like that, but not too sure. The networking stuff.
Okay, yeah. So we will do some networking, and currently in cohort 19, that's what we are doing today. We are working with networks. Like we are learning about networking. Right? So um, if you're not in cohort 19, then probably you would come to meet it.
You think?
Okay. So now before like we start building in the other ones, let's use this one that we've already built. All right. And we'll be using this one to also grab a few concepts as well. Okay, so um, as part of this software, what I can do is I can go into simulation mode, right? And this simulation mode allows me to sort of pause through and then I analyze what is happening within a network before I continue it. But you can't do this in real world most of the time though. So what I'll do is I'll just hide everything, like the protocols that we are trying to use. There's a lot of protocols, and one that I'll actually choose is called ICMP. And if you know the ping command, it uses this protocol, right, the ICMP. So I just want to select the ICMP so that I'll do a ping just like for you to see how one data or like data goes from one side to the other, and you'll be looking at it in terms of the OSI model, right? And then maybe from there, the understanding might start to kick in. So here I'll go to PC0 and then I'll do another ping to this PC right here. Okay, so I'll press the enter key. And now what is going to happen is that something has started. Okay, so what I can do is I can click on this here, right? And I can see a few things. I'm not sure how this can be made bigger, but is this clear at your side?
Yeah, it's clear over here.
Let me see if I could get it to be a little bigger. Uh, I'm not sure what that would be. that doesn't move with the size. So sorry about that. But once we get to the other side, most of the text will be fine. I was trying to move make this bigger, but it's not really picking up. Okay, so um okay, so what I'm trying to say is that you see currently we are starting from PC0 and we are going somewhere to somewhere, right? So we are currently at device PC0 and the source is PC0, which we can see at this point. Our destination is going to this address over here, the address that we set from the beginning. Okay, so you can see that here we are seeing something like the OSI model from layer 7 all the way to layer 1. Okay, but then you can see that here layer 7 is not being used. Layer 6, 5, 4 are not being used. Not because they are not important, but because what we are using at this point doesn't go all the way to that side. And we will see why that is the case soon. So here, all that I'll do is I'll just step through this, right? So here, I'm just trying to show that like when we are trying to send something from one side, it builds up before it's able to get to that other person. Okay, so here, what I'll do is I'll move to the next. So you can see that here, it sends it to this PC here. So this PC also has to make some, like has to process it. Okay, so here I'm sending an ICMP message. Basically, I'm pinging this device. So now that it has received it, if it is able to reply me, then I can say that I am able to reach this device over here. So when there's an issue and then this device can't reply well, then there's going to be a problem. Okay, so now what I'll do is I'll move again, and then I can see that now when it sends this message, you can see that it's checking, meaning that this device over here has been able to reply to it. And that is how we are able to see this first message. You can see the first reply. Okay, this is how the like the thing goes in between, like or back and forth. But it happens so fast that we don't usually see that. So first of all, it has received the first one, and usually it sends 4 packets. So a packet is just some data that we send from one network or from one device to the other. So currently, I'm just trying to keep it, let's say, simple as much as I can. So then it will send another one, like the same thing. It will send that, and then this device will reply. It will send another one, and again, it will reply, and then back and forth in that way. Okay, so whenever you are doing a ping, and then the device on the other side receives it, it will send a reply, and if it replies correctly, you see that. But then if something doesn't go right, then there's going to be a problem. Okay, so as part of that, let's see something. What if I was to ping something that doesn't exist? So let's say I ping 192.168.10, but let's say 56. This doesn't exist anywhere. So let's go here. So I'll press the enter key. All right. So I'm trying to ping something that doesn't exist. So it's like you trying to call someone who doesn't exist. All right, calling a number that doesn't exist. Let's see how this is handled. So I click on the next, and you see it doesn't go anywhere. It doesn't go to this PC at all, right? Because the IP address that I give to it is not valid. Okay. So here, right here, I can see what is happening over there. But on the PC, nothing is really showing up yet. All right. So I'll hit the enter key, like the next one here, and you can see that it's saying that the request is timed out. So here, I'm just trying to show some examples of what can happen, or like the kind of error messages or the messages you can be receiving at some point in time. Right? So this wouldn't work anyway, like because this device doesn't exist. Okay, so let's get rid of that. So what I would just like to do at this point is to like we've seen this one over here, and then I mentioned that when we have two devices that are interconnected directly to each other, we call that a peer-to-peer network, or we can say a point-to-point network. Okay. So there are other forms too, and what I would like to introduce is the switch that we used previously. So here now, what I'll do is, what if I had multiple PCs? Like if I had a third PC at this point, for you that are using laptops, you can see that at the back of your laptop or wherever it is, there's a port, right? There's a port that looks something like this. Okay, there's a port that looks something like this. All right. So this is where we connect the devices. Okay. So currently, since this is just one here, if I try to connect this one to the other one, and then I try to also connect the other to the other like that, I won't have enough ports. And probably maybe you are seeing this one here. This is not what I'm talking about. It's something different. Okay. So when we have multiple devices that we need to connect to each other, we need a different, or we need an intermediary device which will do that for us, and that is the switch. Okay, so when we bring in the switch here, we're able to see that we can essentially just come to this side, connect this here, connect this there, and then connect this one as well. Right. So basically, the switch here is just serving as the intermediate device that we can use. Okay. So from here, if this device sends something, it will get to this device, and then this device will determine where it has to go to. Okay. So when we are talking about the OSI model in particular, the switch over here is operating at the layer 2, which is at the data link. Okay, so when we talk about the data link over there, it's really talking about the standards, or like the kind of thing that it's using to do that. Okay, but also when we talk about the physical layer, we are actually talking about the kind of cable that was used. Okay, but when we are the data link, we are talking about, let's say, what standards? Is it Wi-Fi? Is it Ethernet? Well, Ethernet meaning like mostly cable. If you can think about it in that way. Okay, so here we've changed the network a little bit to make sure that it is going from the device to the switch. Then from the switch, it will determine where it has to go to. Okay, so now we've seen that I can ping this device here. PC0 can ping PC1. Okay, so let's try again with this one over here, and then let's see how it would go. Okay, so what I'll do here now is I'll again, okay, so this time let's ping PC0 from PC1. Okay, so I'll do ping 192.168.10.1. All right. So here I'm going to ping PC0 from PC1, and let's see how it will travel back and forth. So here now, what it will do is it will send the request to the switch, and then the switch would also have to decide where it has to go to. And this switch has been able to learn something we call a MAC address. Okay, so we'll see that. So now this switch is able to also send the request to the right device, and then the device will also respond, and the switch will also just send it over to the other side. So the switch is smart enough that it is able to know that, okay, well, this device here that is sending the thing to is moving from here to the other side. Okay, so I just wanted to use this one as a means to just show that, well, when we are actually communicating on the network, it moves from one side to the other in ways that we do not see, but then just to put it in a milder way so that we can step through it as we go, right? And for the final thing, before we leave this environment and then we go to the more realistic place, right, where we would deal mostly with what is more interesting to us. Okay, we would also bring up a server. Okay, so what I'll do is I'll bring up a server, and what I'll say, I'll go into the configuration of this server. I'll go to the services, come to HTTP, and I see that it is already on. Okay, so what I want to do is if you just go to the go to the IP address of this server and then just do something over there. Okay, so there's something called DNS, which we will talk about another time, but that is what allows you to be able to use names on the internet, something like google.com or those kind of things. But since we've not set the DNS, we would have to use the full IP address. It's like you not saving the name of the person. So each time you have to call the person, you'd have to type in their number. Okay, so what I'll do is I'll just set an IP address for this guy as well. So I'll set this one to be 192.168.10.10. Okay, so quickly then I'll also connect it to the switch. Right, so you can see that currently all of these are connected to the same device. Right, and when this device over here spoils or misfunctions or malfunctions, we know what would happen, which is not a very good thing. So usually we call this a single point of failure, right? Whereby when one device fails, everything that is dependent on it also fails. Okay, so now what is going to happen is that I'm going to go to PC0, and just as we are on the browser, I can go to web browser, and then I'll just go to the IP address that I gave this guy here. So let's wait for it. So now I'll enter the URL. So I think it's 50 that I gave it, right? Let me confirm. Okay, .10. Okay, so for you, probably this would have been something like facebook.com or google.com in that sense. But really, when you type these things, they are translated to this before you even receive the page that you see. Okay, so I'll press the enter key and then let's see how it's also going to go. And before we do that, let's step to the simulation. And the other thing that I'd like to do is whenever we are working with websites, we are talking about HTTP. So what I'll do is I'll come and select the HTTP so that we can only see that traffic. Okay, so I'll select HTTP, right? Okay, so now from PC0, I'll start to go to HTTP over here. So it's okay. All right. So yeah, it has started the connection, right? So currently I've just set it to play. Okay, so now you can see that it sent it from here to the switch, and then this over here also sent it to the server. Now the server is also sending it back to the switch, and then the switch will also take it back to the PC, right? So you can see that now it is checking correctly, meaning that it has received everything that it needs to receive. And that is how we are able to get this page over here, right? But within the process of getting this, a lot of things really went down to get that. And you can see just to get this small page over here, we had to go through 1, 2, 3, 4, 5, 6 back and forth, right? To do something like, I want this, give me that. Okay, this is it, take it. Okay, so a lot of things happens when we are dealing with networking. Oopsie. Okay, so whenever we are dealing with networks, things are going on in the background, right? That's why it's important to understand how it's working so that we can manipulate how it's actually behaving, or if something goes wrong, we can like troubleshoot it. Okay, so from here, most of the time we are limited by what we can do, and it doesn't look very very realistic. So what we'd rather do is you get into another area where it's going to be more realistical, and maybe have much more conversation over there. But for now, from what you've seen so far, like what is something that is not making sense so far that you want to be clarified?
So Maxwell,
Yeah.
the other day before this networking, we were given an assignment about SSH. Can you explain how it works? Because I just generated keys, but I have a very rough idea. I don't think I'm correct. Can you explain how it works? The SSH keys.
SSH keys.
Yeah, how it works.
All right, so I'll try to do that quickly, then we can come back. So the SSH keys, they are let's just say a way to authenticate with a server without using the usual passwords that we use. Okay, so um, instead of always typing in your password, you are rather going to give it like some information that, okay, well, this is part of my information, and this is something that I would like you to keep track of. So anytime I'm coming to connect to you, I want you to look at what I've given you already and look at what I'm giving you at that point to see whether it still matches. So if it still matches, then it is true. Or let's say if you like to keep it simple, let's say that the SSH keys are like me telling you something, and then every time I come in, I would like to confirm you know me. I would ask you to ask me what I told you there. Then if you say it correctly, then it's true that you know me, right? But there's actually more to that. But really, it is just an infrastructure that we use to authenticate devices or hosts, mostly used in client server architecture. Right? But it's just a way that we use to or we use for authentication.
Okay, so when we submitted our public RSAs, so how are we going to do the assignments using it? Because I think CLX should give us the public key, or I don't get it. I get the uses of SSH, but I don't get how it applies. Why we did it? Why we submitted our public keys.
Yeah, I think maybe like we could talk about that more, but really it's about the fact that the public key is what the other side uses to authenticate your private key. Okay, so like I was saying that so like the public key is what you tell someone to keep for you, right? So then the private key is the other thing that you use to. Let me try to get something. But what I'm trying to say is that these two things are related to themselves, and only the public key can be used to authenticate the private key, and only the private key can be used to authenticate the public key. So at any point in time, these two things must be available. So you keep the private key and you give the public key to the other side, which you will need to authenticate with. All right. But we can discuss more on how that works. But for now, we are just trying to get a lay on how like network works in general. But maybe after the call, we can talk more about it. Another time.
Okay, thanks.
Yeah. Okay. So I'm supposing that we are all okay since I'm not getting any questions. Do we get what is happening at this point? we understand what we mean by those things?
Yeah, very clear, very clear.
All right. So then let's get into some bit of a more realistic network that we may actually see. Well, though this is fine, but then we are limited to certain things. So what I would like to do is I'll just close these ones out, and then we would.
Hey, Max.
Yeah.
I mean,
Yeah, I can hear you.
I wanted to understand what is the work of the switcher. Do the networks that are connected to the switcher, do they call to the specific address or what?
Okay, so the switch is the device that is in charge of taking data on a specific network and sending it to the right device on that network. Okay, so before we started, I mentioned that we have something like this. We mentioned that this is a switch. When you see a drawing like this, it's a switch, right?
Yeah.
And then this over here is a router, and this again is a switch. Okay, so everything that is connected to a switch is part of a specific network. Okay, like
All right.
it's part of one network, and then the router here is used as the segmentation thing that is used to connect two networks together. Okay, so the switch's job is to make sure that any device that is connected to it. So if this device over here was to send some data or some request on this same network, so to another device which is connected to the same switch, the switch would have been the person to send it to that device. Okay, so that's basically what a switch does. It takes whatever data that is supposed to go to the same network that is connected to it. And by the same network, I mean that anything that is not supposed to go over a router. Okay, so in the sense that this place could have had more devices, but I just put just one here to make it simpler for what we are trying to do. Okay, so that's what a switch is doing. It takes whatever big data is given to it and then sends it to the device on the same network. Okay, so it does a few more things, which I really want to worry us with at this point. But let's say at the bare minimum, that's what it's doing. It just takes data and sends it to another host on the same network.
All right.
Yeah. But then if any time that we need to go over from one side to the other, then we need the help of the router, which will take it from one network to the other side. Okay. So here I have some very simple network over here that I'm trying to use. The devices that I have here are Linux devices. So we are going to use these things to work with what I'm trying to do here. Okay, so here from PC1 is an Ubuntu machine. So I'll log in. So this one gives us a little bit more of a realistic thing, and I always type the password wrongly. So this is PC1. And then this is also PC2. So Ubuntu. Okay. So PC1 is here, and then PC2 is over here. Okay, I've already configured the IP addresses for them, but then what we will do again is we are going to build a network after we are done with a few things, and then see how you can also go about to configure the networks, maybe for a new network or let's say for a new device that you've received. Okay, so these things that you are seeing right here, they are like raw devices, right? They are actually, let's say, they are just like the sandbox that you are using. Okay, and I'll be showing a few things with that. Okay, So this is PC1 and this is PC2. Okay. So now this one over here, this PC over here is on the LAN 1, right? And I didn't really talk about what LAN is, but a LAN is a local area network. Okay, so the local area network is, think of it as what the switch is controlling. Okay, so anything that is connected to the switch is, we can say that it is part of a specific local area network, or like all devices in a particular segment, or think of it that like the devices in your home or the devices in your office at a particular location is a local area network, right? Because of its size and its geographical nature. But if it was, let's say, across cities and across multiple places, then we can be talking about it in terms of wide area network, because the distance from one location to the other is quite large. Okay, so there are other kind of network types, but then I just wanted us to just keep it to what would be more interesting to us. And for the other ones, you can look them up and work with them. Okay, so these two IP address, sorry, these two networks over here. All right, so we saw one network that was like together, but then here we also have a network that is separated by a router. So this is similar to you being on one lane and then another person being on another lane. All right, so if you wanted to get to the other person, you probably have to pick a car or book a flight or use something like that to get to that person. This person doesn't happen to be in the same neighborhood as you are, so you would have to be able to get all the way to that person's place. Okay, but what we are going to really talk about in terms of what we want to do is to talk about the ping command and then also the app command, which we would use to discuss a few things, and then we move on to something else. So here we've already seen the ping command, but then on Linux, right? If you try to just use a ping command like that, it will ping infinitely. It is an example of a while, like an infinite while loop. Okay, so before anything, I'll just check our IP address, which is I'll use the IP-addr command or IP address, anyhow that you like to write it. But if you're on a system that has the ifconfig, you can use that as well. Okay, so here on this device, on PC1, I have this as the IP address, 10.10.10.50 as the IP address. And then on PC2, I have this over here, 10.10.10, sorry, 10.20.20.50 as its IP address. Okay, so think of IP addresses as phone numbers for now. Okay, but there's more to them as I said. So now I want to ping this device, like I'd like to communicate from this device over here to this other device. Okay, so the networks here are not the same, right? And if you like to know more about why that is the case, you can check more on what IP addressing are, or what the different kinds of networks are, and then you probably understand. But one thing that you can see is that here is 10.10.10, and then here is 10.20.20, right? Right. But for now, we wouldn't worry about that yet. All right, so we'll do a ping 10.20.20.20.50. But if you have to just do this, right, it will ping indefinitely, and you can see that the pings are working. I've already set up the network ahead of time, so this will ping indefinitely. It will ping like continuously, right? So what I have to do is I would have to press Ctrl+C to get out of that, right? But then there are other methods to make sure that we're only pinging up to a certain point or a certain number of times. All right, so we can see that at the man page for the ping command, but what I wouldn't do is to bore you with the documentation. So if you like to know more about that, you can check it out over there. But what I'd like you to see is the -c option, which is for the number of times or the count. Okay, so what we can do is you can see that, okay, for this device over here, I would like to ping it for only 2 times, right? And then I'll give you the IP address of the device I want to ping. So I'm just saying that ping the device for 2 times, and that's what it's going to do. So I ping 1 and 2, and then you can see that now it has finished the pinging. So we ping 1, we ping 2, and then that is it. All right. So for the number of times that you would like to ping, you can put that number there. Else it would ping continuously. Okay. So as a matter of fact, what I like to do is to save this as an alias. Mostly, I set it up to 5. Right. So just because we are here, what I'll do is you can go to the vi to .bash rc, or if you are using a specific file for aliases, which is a better option, you can go to vi.bash_aliases, and you can go from there. But for this purposes, all I'll do is I'll just go to the .bash rc file, and then I'll go all the way to the end with capital G. All right, and then all that I'll do is I'll say that alias, and then ping. All right, so I'm just going to say that whenever I write the ping command, I would like it to mean this. I like it to mean that ping like this. Okay, so all that I'm saying is that whenever I write the ping command, I'm actually saying that ping-c5. So now it will wait for the next thing that I'll put over there. Okay, so this way I'm able to write the ping command and still have the feature of pinging just 5 times. Okay, so if this is something that you like to do, you can also try it out. Then after I'm done, I'll just source the .bash rc file, because if you don't do that, it wouldn't take effect. So now I've sourced it. Now what I'll do is I'll just ping the device that I was talking about. So 10, 20, 20.50, and now it should be able to ping only 5 times and then cut. All right, so now you can see that just by using the ping itself, I've still been able to ping 5 times, but you can still keep it to just using the thing like this, right? But most of the time, you would like to ping only for a certain number of times. Okay, so if you like to ping for just 5 times or for a certain number of times, there's one way that you can go. And then since it is something that I do often, I set it as an alias so that I don't have to type it every time. Okay, so that is one way that you can ping continuously, or you can ping for a number of times. But if you're on Windows, I think the default number is just 4, to ping 4 times. Okay. Okay, so that's how we ping on Linux. Right? There are other ways to ping, but this is more simpler. Okay, so the same way I can ping this device over here. I can ping PC1 from PC2. Okay, so here I can see something like 10.10.10.50, right? And this is able to also ping the PC1. And this is also going to do it continuously until I break out with the control T. Okay, so every time that you are on a Linux machine, most of the time it is set to an infinite pinging. Okay, so until you close it out, it will keep on pinging. Okay, so but then if you want to ping for a certain number of times, then that is how you like to do that. Okay, so that's one way to go about that. Okay, so let's say if you are working with a server that you are trying to configure or something like that, and you would like to check its availability, or let's say you've published your web server, or like you've published a web server, and the clients are saying that, well, they are not getting access to it, right? This ping utility over here can give you information of whether the the web server is still up or whether it's not able to receive these things. And ping is one of the things that we use to confirm whether we have connectivity. Okay, but it also has some security features, and some web servers block it, or some servers block them. Right, but there are other ways to also go about that. But whenever we are talking about testing for the connectivity, the ping utility is one of the most sought after. Okay, so if you like to ping something or test whether there's connectivity, then you can use the ping utility to do this. Okay, and if you're on Linux and you like to find your IP address, you can either use ifconfig, or on newer systems, it comes with the IP address command, right? So on my system here, when I do ifconfig, I don't have it. I would have to install it with this command over here. So if you still want to have the old way of doing things, the ifconfig command can be given to you by installing it over here. Okay, so for now I'll be using the IP address command, but essentially they are the same thing. Just that the layout is what is maybe a little bit different or something like that, but they are really about the same thing. Okay, so I was talking about the fact that if we are pinging, you can, or if you are testing for connectivity, we use a ping command, and we realize that by using the IP address command to find what IP address we had before we did anything else. But one thing I would do before I ask whether there's any question is that whenever you are having, let's say, a connection problem and you don't know what the issue is happening, because let's say you are trying to ping another device which is not on your network. Let's say you are trying to ping google.com and it's not working, right? You would have to test whether like you have internet, or whether you have connectivity around yourself, right? And if you're on Linux, what you can do is you can do IP route, right? So here, what it will do is it will show you, or like it will tell you where you are going from one side to the other. Okay. So here you can see something like default via something like that, right? So this default over here, think of it like, if I don't know where this network is, where will I send it to? Okay, so the default is like, if I want to find like the gateway to the outside world, who am I sending it to, right? And it says that it will send it to 10.10.10.10.1, which is the router that I have over here, right? So the router at this point is having two interfaces, one to the left side and one to the right side. So each of the sides have an IP address which is leading to different networks. So like I said, the router's job is to just connect two networks together, or two or more networks together particularly. So whenever you are having issues with your networks, you'd have to first confirm whether you have access to your actual local environment. So now we know that this is our router's IP address. But if you're on Windows and you type ipconfig, that command, you see your default gateway there as well. But on Linux, if you do the IP address command, you wouldn't have that over here. So that's why we have to use the IP route to find it. Okay, so that's one way to go about that. So once we know that our IP address is this, the next thing we can do is say that, okay, well, I want to ping that IP address to confirm whether it is up. So if we ping this IP address here and then we figure that it is up, then we can find out other things to check whether, okay, well, is it the other side that is not responding or something like that, right? So this ping command can be used to like hone in on network problems, and then figure out what is going wrong and what is not really working as we planned. All right. So based on this ping thing that we are doing at this point, like how have you tried the ping command so far? And like, is there anything that you seen that you think you like to share, or any questions that you have so far? Oh, we are good.
Yeah, we are all good. No question so far.
All right. So if that's the case, let's check out a few things, and then we would like hold it on for today. So still on the network thing, right? So the ping utility is used mostly for these things, right? But then there's also another one that we call the trace set or trace route, depending on where you are coming from, right? But the trace routes, where I can get it from is the net tools. Okay, so I actually have a different network that I would like us to look at. Okay, so give me a moment. Let me bring that one up. All right. So here, this network was used to explain the fact that there are two different networks, but here this network over here has access to the internet. And like I said, whenever we use a cloud, we are talking about the ISP, or like your internet service provider, or the internet itself, or a network that we don't really need its whole detail, because I can't like visualize the whole of the internet. So that's why we just use a cloud over here to show that. Okay, so I'll bring up the devices, and then let's wait up for them to come. Okay, so I have one device that is a Windows PC, just so that at least we can have some familiarity for the people who are mostly comfortable with Windows. And then also here I have one for Linux. So the Linux machine is already up. Okay, so now, as I was saying, right, whenever we are trying to work with networks, we can try something. So like I said, this one over here is able to go all the way to the internet. So I can say ping google.com, right? So now I can try to do that, and I think I'm getting an issue. Okay, yeah. So it's pinging now. Okay, so you see, it took a while for it to do that, and mostly that is when the DNS thing is actually happening. Okay, so here you can see that the device here is able to go all the way to Google from here, right? So also, I think the place that I would rather like to show more is this place. Okay, so here I'm using a very old Windows version, so that it is easier for us to like I can just work with it easily, for the sake of like space and stuff. Okay, so here in the same way, I can come to the command prompt, and like I was saying, I can do an IP config for the Windows folks, and the Windows here's where you would see your default gateway. So the default gateway is how you get off your network. All right. And then what you may not be seeing at this point is the router that you saw in the other one. Right. But again, like I said, the cloud over here is used to just show all the things that you don't need to worry about for the network. Right. So that is also implemented somewhere, but just not visible to you. So here you can see that here we are also able to have our default gateway. In the same way, I can ping google.com. Right. So this is also happening correctly and nicely. But then, like I was saying, what I'll show up here is like some other things, right? So we've seen that when we have two devices communicating of the same type or of the same entity, as Israel was saying in the beginning, as in they are all Windows machines, or they are all Linux machines, or they are all something machines, they're able to communicate. But it doesn't always have to be like that. But here you can see that we have this IP address here, which is 192.168.122.215. Okay. And then also here, I have another one, which is an Ubuntu Docker machine. Okay, so on an Ubuntu Docker machine here, I have the screen, and then this place I have access to the IF config. So this device over here has this IP address. So what I'll do is I'll ping it. I'll ping the Windows machine from the Linux. All right, so here you can see that still it's working all right. Okay, so everything is working okay, and then it looks fine. Okay, so the entity parts that I was trying to say that is not based on the same kind of entity is what I try to just show here. Whether it's Windows, Linux, or whatever thing, it's able to communicate correctly because of the TCP/IP that we are using, right? So mostly the ping command is very much used. Okay, so now there was one command that I was saying that I'll show up here. It's called the trace route, right? So this trace route is able to show you like, okay, from here I went here and then went there and went there before I was able to get to where you asked me to go to, right? So like I'm going to ask you for the direction to a particular place. So you tell me that, okay, I went to this location, I checked here, I couldn't find it there, so I went to the other side, or like just basically you're going to spell out how you got to the location that I asked you to go to. So here, let's say I'm trying to go to google.com. So let's see how this PC over here is able to get from here all the way to google.com. Okay, so we do that with the trace route command, right? And you need the net tools on Linux to be able to do that. So now let's just wait for it to start bringing up, and you can see that it's going through. So from my PC here, from this PC, it went all the way from here all the way to this place before it got to the Google web server, or wherever the thing I was pinging was, or wherever I wanted to go to was, right? So that means between me and Google at this point, there are 16 hops away, right? Like there are 16 things between me and Google, like for me to get to that side. Okay, let's see for the same thing for the Windows. And in Windows, what we do is we call it trace sets. Okay, so our trace sets for the same thing, google.com. And then yeah. And then one thing that I didn't mention is this thing. If you see the stars, it means that when it got there, there was a communication issue, so it tried a different path. So yeah, you can see something similar is happening on the Windows side as well, right? And usually, how long this takes is also like a reflection of how your network is, and this is like a virtualized network, so it doesn't really matter much, but we can still see that it's taking quite a while from my PC to go all the way to Google, right? So if I should type google.com in my browser right now, this is like something that is going to happen. It has to go through all of these to get to Google for me before I can get access to Google, right? So if you are having, let's say, network lags, and then you don't understand where it's coming from, you can trace your route to wherever you are trying to go to. Maybe there's something that is blocking, or something that is not resolving correctly, or maybe like the path that it is using to get there is very long, right? But most of the time, network tries to use the shortest path possible. But at times, one device can take a long time to respond, which will make the connection lag a little bit, right? So we've seen the ping command, and we've also seen the trace set command, as well as the trace route on the Linux variant, right? But then on Linux also, we also have the trace paths, and there's trace this. But for now, what we only concentrate on is the trace route, right? So if you want to find how your device goes from wherever it is to wherever you are trying to send it to, you can use a trace route to figure that one out. Okay, so that is something that you might like to try. Okay, so in the same vein, we can also use a device to check this same thing. Okay, but then for now, I think I'll save that for another session where we can use a device called Wireshark to figure out a few things. Okay, but essentially, when we are trying to work with networks, this what is mostly happening. We have our networks up in this way. Maybe for you have two PCs at home. You have some Wi-Fi sitting somewhere. You just connect the two PCs to it, and you just browse your internet, and you don't worry about it. But actually, what is happening is that in the background, there's a lot of things happening. Okay, so like I was saying, I can come to my internet browser and then go and do something over there. But for now, let's talk about what we've seen so far: the trace route and then the ping command. Is there anything that is not very clear to you? Are we together?
Personally, I'd say I'm okay.
All right. So
Over here as well.
all right. Okay. So in the next section, I'll probably ask you to tell me what each of these things mean. Like, if I see this, like, what does it mean? What is it really pointing to? And those kind of things, right? But like there are things that we have to worry about, right? So in the beginning, when I started, I mentioned that the applications we talk about is not really about the browser and those kind of things, like those things, right? But really about some protocols that we use. And all of these protocols, or most of them, have port numbers. And the one that we are going to be concentrating on for now, and then we'll try again another time, right, is the HTTP, okay, and then the HTTPS. Then we can also try and then talk about SSH, but not very much. It's mostly just about the connection. But for now, let's just talk about the HTTP, right? So the HTTP has a port number of 80. Right. So whenever we are connecting to the websites and they are using the HTTP protocol, we are using port 80 to get there. Right. And a combination of an IP address and a port number is what we call a socket. Okay. So usually there's a command that we use to find them. It's called a net start, and it's also available on Linux as well. So on Windows, you can see that it's also called net start, right? So you can see something like this. Let me rather bring up my Linux machine, since that's what we would normally be using. So called net start. Right. And usually when you run it like this, you probably wouldn't see much. Right. So what we can rather do is say that, well, I'd like to find all the ports that are listening, right? So if we have an application, like let's say a web server, it has to be listening. For example, how if we go to google.com, we receive it. It's because the server that is serving google.com is listening for requests. Okay, so now when I do the netstat -l on Linux with the -l, we are trying to say I want to find all that everything that is currently listening. But looks like here I don't really have much because there's not really something that is running a lot of things. Okay, so I think I'd rather use the like the Windows for now. So come in. Okay, so what I'll do is this. So okay, so what I've just done is that I'm just saying that show me the network statistics, if we should say, and I want all of them. And the dash n over here is just saying that don't resolve the names, like give me the actual IP addresses. Okay, so here you can see something like 0.0.0:135 is a different form of port numbers. But then I was saying that the combination of an IP address and a port number is what we call a socket. Okay, in the same way, we also have quite a few things down here. We have 192.168 this colon 123. The port number 123 is for NTP, which is the network time protocol. It is the thing that is in charge of making sure that our time is in sync with whatever server that we are connected to, right? Basically, it is what gives us our time. Okay, and I'd like you to also look up what TCP is and what UDP is. They are some of the things that we couldn't really talk about. But as a final thing, what we will do is this. We will try to open up a web browser. But before we do that, you remember that in the other environment, I had to like go to the simulation environment to do something. But here, what we'll do is we will use a realistic device, or sorry, something called Wireshark. Right? And what is going to happen is that I'm just going to start a capture, and then what is going to happen now is that I'll go to the Internet Explorer, which is a very old something, and you can see just by clicking on that, I can see quite a lot of things that's happened just now. But for now, let's not worry about that yet. What I want to do is to go to google.com. Okay, and before that, what would also happen is I'll just set it to I'll just refresh. Oops. Give me a moment. Let me. Right. Let me restart the capture. So the thing is that by default, even if you're not doing anything, there's still something going on the network. Okay, so here I want to go to google.com, and when I press the enter key right now, you can see quite a lot of things that just happened just by pressing google.com, right? So I wanted to go to google.com, and then this is where we started from, and then I'll take it a little bit, and then we would maybe continue another time. But here's where everything started, right? You can see that. Okay, let me bring it up a little bit. I hope it's clear, right?
Yeah, it's clear.
All right. So you can see that my IP address was this, or basically let's take it this way. Saying that, okay, there's my IP. Yeah, Google somewhere on like there's something that is called a DNS server, which is in charge of taking the google.com and then making it or translating it into an IP address. So you can see that here I sent it to a specific IP address, which is my my default gateway. Okay, so this is my default gateway. So I'm sending it from here. This is a source. So the source is my let me just show this. So my IP address is 192.168 122.25 so 215, right? And my DNS server is this, right? So that is what is happening here. The source is the Windows PC that you're just looking at, and then the destination is the cloud that you saw, right? So this over here took the request and then sent it to the internet, and then it received some data, right? So you see that currently here, this device here has responded back to my PC, right? And you can, I'll just like you to be seeing the protocol over here, right? This protocol here is DNS, right? That is a protocol that allows us to convert names to IP addresses, right? Just like you can convert your like your phone, like your friend's phone number to a name, and you just call the name, right? So that is what is happening here. So you would have to take a look over here and then see what is here. So the DNS uses a port number of 53, right? These are some few port numbers that you would have to know. It uses a port number of 53, right? So we received something. Right? So first of all, we sent a query and then we received a response. So the response was that google.com is at this IP address. Okay, so in the same way, when you call a friend, the call will actually go to the friend's number, not to the name per se. Okay, so that is how we get this. So when we say google.com, we don't go directly to google.com. First of all, the name google.com is translated into an IP address. Then that IP address is used to do what it has to be used for. Okay, so you can see that right after the response was given, my PC, which is over here, sent sent a request to the IP address that was returned as for Google. All right, so here now I'm sending my request directly to Google. So first of all, I sent a request looking for the IP address that Google is using. Once I found it, now I'm going to communicate directly with the Google IP address. So at this point, I'm not communicating with the name google.com. It's the actual thing or the actual IP address that Google is at. Okay, so there's these three things that I'll just like to point out. We call them the TCP three-way handshake. They're called a SYN, SYNAC, and then ACK. Okay, so every time we are using a protocol called TCP, we have to set up a connection. It is just like how you would call a friend, right? Let's say, hello, are you there? Then like the friend will also respond like, yeah, I'm there, or something like that, right? Or essentially how you have to call the person first, the person has to answer before you can do anything. And as you continue to talk, like the way that we are doing here, after some time, I'll ask you, do you get it? Do you understand it? Before, if anything else, I would add it up, right? So that's just, let's say, a summary of what TCP is, but you can check it out and then understand more of that. Okay, so there's a lot of things that goes on when we are just even doing something very simple. Okay, so we can see that we have that I'm sending some data from my PC to Google, and Google is listening on port 80, as I was mentioning that the HTTP is listening on port 80. So that 80 in the bracket is this. The IP address, sorry, the port number that my PC is using is something random, and we normally call those range of port numbers as ephemeral port numbers or temporary port numbers. Okay, but then there are some registered or well-known port numbers that are used by applications like 80 for HTTP, 443 for HTTPS, 53 for DNS, like quite a lot, 123 for NTP. There's a lot of them that we would be using, but which we don't have to really memorize, right? So the thing here is that when we were able to get connection to the Google server, then it was able to receive what we wanted, right? We said that I wanted to get something. I want to give me something. Give me that. Get me that. Okay. So here with the HTTP that we are working with, right? The information here is all plain, right? I could go ahead and then show you where like the like the data that we are seeing is coming from, right? But for now, we wouldn't really go to that much. But just to show that here, I'm just showing something here. This is around the time that we received the web page, like the content that is hosting the web page, that HTML thing that allows the web page to look like a web page, right? But before that, we requested for it at this place. So we said, "Get me something," and then the server replied at a particular point. Okay, so now if you are like if you've seen HTML before, you'll be probably like see this code, like you'd see something similar there, but for now, like this looks very like it's been truncated because of the size, right? But this is exactly what it's on the web page, right? We could have seen everything there. Also, we asked for the for a specific image, because remember that on the Google website, there's an image that has to load up. Right? This image right here has to load up. So we are asking for the image, right? So we asked for the image, and then we got the image somewhere around here. Okay, so here I could come in, right? There's a way that we can actually go ahead and then grab the data that we received, right? But for now, let's just not like worry about those things yet. And like it's for some of these reasons why that we have the HTTPS. I could essentially just go through all of these and figure out what's happened in this connection that we just did, right? And every connection that we did to, I see the exact thing that was put over there, right? So that is why we actually have the HTTPS, so that it can mask everything that we are doing, so that it's much more secure. Just like the SSH that we have, it's able to not make it plain, right? Maybe another time we can check that, but still trying to keep it to the developer thing, right? But since mine is more like that, so I just wanted to show a few things of like when we just type something like google.com, this is like how much things happen in the background just by just saying that, okay, well, I want to go to google.com. This is like starting from this side all the way to this side. That is all that we got, or like all that we had to do to get to just google.com. So there's a lot of things that goes on in the background to get us what we want when we do these things. So I'll just edge that maybe you can check out more on the specific protocols like HTTP, HTTPS, and DNS, at least for now. All right, and also SSH. Okay, so check them out. Try out the ping command, the trace routes or trace sets if you're on Windows, and then the next start command, you can use them and try to understand them. Right. So currently, now that I have opened up a web page, let's see what my